My name is Ruth, and I'm a research scientist at RENCI at UNC Chapel Hill. And part of what we do is we develop new features for the ExoGENI testbed, and I'm going to show you a few of those today. So the new features we're going to show you is how to use wide area SDN on ExoGENI, and show you some of the new modified features that we've implemented that are pretty powerful and some people are interested in. So a lot of what's driving our work is the need to get domain science applications running on top of GENI. So we have, so you can have different domain scientists using lots of the GENI resources, including all of the network resources that go in between them. However, there's some limitations. When you try to get your domain science applications to scale really largely, we have a lot of issues to get the network working. So three of the issues are that we run out of VLANs within the test beds. We have limited quality of service guarantees. So if you ask for a network circuit, you may or may not get the quality of service you're looking for, and lots of failures. So sometimes when you ask for network circuits, they just don't come up and they don't work very well. So we're trying to figure out a way around this, and our solution is to create a big SDN network switch virtualization. So what this would look like is a big SDN controlled switch that logically connects a bunch of pieces of your slice that are spread out all across the test bed. However, under the covers, what we're going to do is we're going to create a bunch of nodes and switches inside of the SDN switch that the users don't really see, but allow us to connect out to whichever racks the users want to use. And this will be controlled by OpenFlow controller, and each of the nodes here will be running an Open vSwitch, OpenFlow switch. And what this allows to do is to identify any failures that happen and adapt the user slice to any failures that occur, and we'll be able to monitor performance to see if the performance degrades, and then we might be able to adapt to get better performance. And we also might be able to use a minimum number of the resources to conserve some of the VLANs that are crucial to making everything work. What we have is a slice that's already running, and it looks something similar to the slice I showed in the PowerPoint slides. So there's about 4 nodes in the middle. There's these 4 switch nodes, each one of those running Open vSwitch, and there's an OpenFlow controller that's actually not in this slice for the purpose of this demo. And then there's 4 different racks that are using that have compute nodes. They happen to be racks at Chicago, at Starlight in Chicago, and Pittsburgh Supercomputing Center, University of Florida, and what was the last one? Is Wayne State University in Detroit. This is one of the nodes in this group, and it's pinging its neighbor, and you can see it has really low round trip time. And then we're going to have it ping in the next group over, and we can see that the round trip time goes up to 24 milliseconds. If we do the next one over, then we can see it goes up to 70 milliseconds. And finally, if we go all the way around the loop, it goes up to 145 milliseconds. And I'm going to let that run for a while, because now we're going to manipulate this network. Right? So say this 145 milliseconds is too slow for whatever your experiment is, you can now fix that. So I can come over here, I can delete. I can delete the part of the slice, delete the link that's between the middle pieces of the slice, and submit the changes. This is going to take a minute. There it goes. Okay. So I submitted that request to modify the slice, and you can see now the ping is unreachable because there's no path between the 2 nodes, and we have the report back that it was successful. So now what I can do is,
the idea with the Internet of Things nowadays.
Now I can query for the manifest again, so we can see, we just updated so we can see what we actually have now. And if you remember, we had connected switch number 2 here with switch number 3 here. And what I'm going to do is I'm going to draw in a connection between switch 4 and switch 1.
Wi-Fi router, all within your own network.
And I'm going to submit that now. And what this will achieve is the ping that we have going here will now be going on a more direct path than it was previously. So you can see this, the submission completed, and we now have modified the slice. Ping has restarted on its own, and you can see that it's 21 milliseconds about, which is much faster than the 140 we've done before. And we can now re-query the manifest and see what actual resources we got to complete this. So now we have the same picture, but if you remember before we had the ring was going the other way, and now we've optimized it for whatever application we're going for. So that's my modified demo. Hope everyone wants to use it. Come to exogeni.net and learn how.